good afternoon, class. So for today, we will be discussing operations on radicals. So I will show you how to add, subtract, divide, and multiply our radicals. So let us first look for the learning target for our today's lesson. Perform operations on radical expressions. Okay, so for our next, let us recall first the given equation. You can write this down and then I'll show you the answer later on. So let us recall. Draw a line to show the radical expression in its simplest form. So what would be the simplest form? So we already discussed this during our last meeting on how to simplify our radical expression. So okay, let's begin. Let's check. Okay, so 4a raised to 8 will be equals to 2a squared. Then the square root of 50m squared n for the fourth power is equals to 5mn squared, square root of 2. Then 3 cube root of 8x fourth y 7 is equals to 2xy squared, cube root of xy squared, and 3y squared square root of 5x over 4. And then the last one, we have 3x squared, square root of 5, y squared. Okay? So next, let me show you this one. Let us discuss this. The operations on radicals. So we are going to add and subtract radicals, multiplication of radicals, and division of radicals. So the next is, how do we add or subtract a radicals? In adding or subtracting radicals, we have to make sure that these are similar. So similar radicals are radicals with the same index and same radicand. So for example, the cube root of 4 and 5 cube root of 4. So the next is we have 2 square root of 7 and 5 square root of 7. And then 3 square root of 8 and square root of 8 over 3. And negative 2 square root of 2x over 3 and 3 square root of 2x plus 5. So as you can see from the given examples, the radicand and the index are the same. So we can now add or subtract the given radicals. Note, so let us remember this, that only similar radicals can be combined into a single radical. So let us first perform the operations on how to combine into a single radical. Okay. So for example, we have 2 square root of 7 plus 5 square root of 7. So we are just going to 2 plus 5 and then square root of 7. Since the radical 7 to the given equation is the same. And next, so our answer would be 7 square root of 7. So we are just going to add the whole number 2 plus 5, which is equals to 7, and then square root of 7, since square root of 7 has no perfect square. Next, for another example, we have 3 square root of 5x minus 7 square root of 5x. So it is a subtraction. So first, we can subtract the whole number 3 minus 7 and then 5x. Since they have the same radical, we can combine them into a single radical. So the final answer would be negative 4 square root of 5x. Okay, our last example, we have 3x cube root of xy and minus 2x cube root of xy. So cube root of xy is also the same. So we can combine them into a single radical. So 3x minus 2x and cube root of xy. So we already combined the two given radicals. So the final answer would be x cube root of xy. So it's easy, class. You can follow. Okay. So, what if the radicals are dissimilar? So, what should we do if the given radicals are similar? So, first is, if the radicals are dissimilar, we just need to simplify the first then combine into a single radical. So, for example, we have square root of 8 plus square root of 50. The answer would be square root of 4 times 2 plus 25 times 2. So, we think of two numbers wherein our given radicals can be multiplied into a perfect square. So, as you can see, we have 4 and 25. Then, the next is, so, negative 4 times, it's square root of 4 times square root of 2 plus square root of 25 times square root of 2. So, we can simplify them. So, we have 2 square root of 2 plus 5 square root of 2. And now, for our answer, we have now 2 plus 5 square root of 2. And the final answer is 7 square root of 2. I'll give you another example. So, we have 5 square root of 18 minus 2 square root of 32 minus 3 square root of 8. So, first, let us look for the numbers that has a perfect square or a perfect cube. So, we have 5, 9 times 2 is 18, minus 2, 16 times 2, square root of 16 times 2, and 3, 4 times 2. So, the next step is, we are now going to, okay, and then next one we have 5 times 3, square root of 2 minus 2, so square root of 16 is 4, so square root of 2 minus 3, the square root of 4 is 2, the square root of 2. Then we have now 5 times 3 is 15, square root of 2 minus 4 times 2 is 8, and square root of 2 again, minus 3 times 2 is 6, then square root of 2. Then, we have now 5, 15 minus 8 minus 6 is square root of 2. So, our final answer would be square root of 2. Easy? Yes, easy. Okay. In multiplying radicals, there are 3 cases to be considered. So, what would be these cases? Case 1 indicates indices are the same. Use the property n square root of x times n square root of y, wherein n would be equals to square root of xy. Then simplify by removing the perfect n powers from the radicand. And example, we have here square root of 2ab cubed times square root of 8ab. So, since we can simplify them, so we have now, as you can see here, 2 and 8, and then a times a, then b3, and then b. So, this will be equals to 16 times a squared times b4, and then we separate them. We have now square root of 16 times square root of a squared times square root of b4. Now, the answer would be 4ab squared. For our case number 2, indices are different but radicands are the same. So, what should we do? We transform the radicals to powers with rational exponents. We multiply the powers by applying xm times xn, which is equals to xm plus n. And then we rewrite the product as a single radical. Then simplify the resulting radicand if necessary. For example, the cube root of square root of 5, the cube root of 5 times square root of 5 is equals to, so we transform them into an exponential form. We have now 5 and 1/3, 5 raised to 1/3 times 5 and 1/2. This would be equals now to, following the xm times xn is equals to xm m plus n. We have now 5, 1/3 plus 1/2 is equals to 5, 2 plus 3 is over 6. So now, we have now here 5 over 6. And we transform this again, the exponential form into the radical form. So the final answer is sixth root of 5 raised to 5. And the final answer would be 6 root of 3,125. Easy? Okay, for the case number 3, indices or radicands are different. So what should we do? We transform the radicals to powers with rational exponent. We change the rational exponent into similar fractions, and we rewrite the product as a single radical. And then simplify the resulting radicand if necessary. So, for example, the fourth root of 2 times square root of 3. So, first, we transform these radicals to the rational exponents. We change this to the exponential form. So, we have now 2 and 1/4 times 3 and 1/2 is equals to 2 and 1/4 times 3 raised to 2/4. Next, we have now the fourth root of 2 times 3 squared. And then fourth root of 2 times 9. Then fourth root of square root of 18. So that is the 3 cases of the multiplication. So how do we multiply binomials involving radicals? So for example, we use the property for the product of two binomials, then simplify by removing perfect end powers from the radicand or by combining the similar radicals. So example, square root of 2 plus square root of 7 times square root of 8 minus square root of 6. So this would be equals to square root of 2 times 8 minus square root of 2 minus 6 plus 7 times 8 minus 7, 6. Then, we multiply now. 8 times 2 is 16. 2 times 6 is 12. And then, 7 times 8 is 56. And 7 times 6 is 46. Then, we can now again solve. So, we have square root of 16. And then, 4 times 3. 4 times 14 and negative minus 42. So, our final answer would be 4 minus 2 square root of 3 plus 2 square root of 14 minus square root of 42. So, easy class? Easy. Yes. Okay. Now, how do we divide or in division of radicals? So, this is the special cases again. So, for case 1, radicals of the same index. Use the quotient rule. So, we have now the n square root of a over n square root of b, which is equals to n square root of ab. Okay, so the rule states that the quotient of the two nth root is equals to the nth root of the quotient. So we have here an example, square root of 32 x to the 4th y cubed divided by square root of 8xy. So this would be equals, or this can be written by this. 32x 4th y cubed square root over square root of xy. So we are just going to multiply them. So 32 times x4 times y3 over 8 times x times 8. So as you can see, we use the quotient rule. So for this example, our answer would be square root of 4x cubed y squared. And we simplify. So we have now 2xy square root of x. And dividing radicals, if the result contains a radical in the denominator, it is not considered simplified. So, a process called rationalization is needed. It is a process of simplifying a radical expression by making the denominator free from radicals. Example, we have 2 divided by square root of 3 is equals to 2 divided by square root of 3. So, we multiply it, the denominator, square root of 3 over square root of 3. Now, we have 2 square root of 3 over square root of 9. So based from the process, which is the rationalization, we have now the final answer 2 square root of 3 over 3. So we already make the denominator free from the radical sign. So the case number 2 for division, radical of different indices. So what should we do? So letter A, we transform the radicals to powers with rational exponent. And then for B, we express them as radicals of the same order. And then for C, rationalize the denominator. Okay, so for example, here we have cube root of 3 over square root of 3 is equals to, so again, we transform cube root square root of 3 into an exponential form. We have now 3 raised to 1/3 over 3 raised to 1/2. So this will be equals to 3 raised to 2/6 over 3 raised to 3 over 6, which we transform it again to our radical form. So we have the 6 root of 3 squared over the 6 root of 3 cubed. This will be equals now to, using the quotient rule, we have now 6 root of 3 squared over 3 cubed. And from the lesson earlier that I said that we need to free the denominator, we use the rationalization. So we multiply now 3 raised to 3 over 3 raised to 3. So we have now the 6 root of 3 raised to 5 over 3 raised to 6. Now, we need to free the denominator, so we need to use the rationalization. So our final answer will be 6 root of 243 over 3. And for our case number 3, radicals with a denominator consisting of at least 2 terms. So what should we do? First, we rationalize the denominator using its conjugate. And next one is, the conjugate means two binomial radical expressions that have the same numbers but only differ in the site that connects the binomial. So let us look for the example. We have 3 over square root of 3 minus square root of 2. So this would be equivalent to 3 over square root of 3 minus square root of 3 times. We use now the rationalization by using its conjugate. So we have now square root of 3 plus square root of 2 over square root of 3 plus square root of 2. So for our answer, it will become 3 square root of 3 plus 3 square root of 2 over square root of 9 minus square root of 4. So, we do the operation. The answer would be 3 square root of 3 plus 3 square root of 2 over 3 minus 2. And for the final answer, we have now 3 square root of 3 plus 3 square root of 2. Easy? Yes, it's easy. Okay. So, for your activity, you can write this down and you can try to solve this and we will answer it later on. Okay? So, I'll give you time to answer.